Hey, 6th grade, it's lesson 4.4.1, all about ratio tables. I can scale up and down to calculate equivalent ratios. So what is a ratio table? It's a tool that helps us organize information to show equivalent ratios. Let's jump right into this. I think you're going to catch on quickly. Example number 1. Ben drinks 1 glass of milk, 1 glass of milk, 1 glass of milk, 1 glass of milk. For every 2 cookies, here's 2 cookies, here's 2 cookies, here's 2 cookies. Ben drinks 1 glass of milk for every 2 cookies that he eats. We're going to continue this pattern, so he eats multiple cookies and multiple glasses of milk. So now here's 2 cookies and 1 glass of milk, here's 2 cookies, 1 glass of milk, here's 2 cookies, 1 glass of milk. I can see that I repeated this 1, 2, 3 times. So we can draw an arrow for the cookies to say times 3. 2 times 3 is 6. And we can draw an arrow from the milk. 1 times 3 is 3. Why times 3? Because we repeated the pattern 3 times. Ben is really hungry and really thirsty. He's going to keep repeating this pattern. Now we can see this pattern 1, 2, 3, 4, 5, 6 times. All right, so I can also see that there are 1, 2, 3, 4, 5, 6 glasses of milk. That's right down here, 6 glasses of milk. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cookies. That's right here. So without the picture, I can see a couple of things here. I can see that we can go from the 6 to the 12 by multiplying by 2. What that means is if we just doubled this picture from before, we would have 6 repeats. That would get us to the 12 cookies. That's why it's times 2. And if we times 2 the cookies, then we need to times 2 the glasses of milk. Right? That's one way to find these numbers in this last in this last column. In this problem, we also could have just jumped right from the very beginning and said 2 cookies times 6, because we repeated the pattern 6 times, is 12, and 1 glass of milk times 6, because we repeated the pattern 6 times, is 6 glasses of milk. Cool. Seems pretty easy, especially when there's a picture to help support us. Sometimes, though, we need to scale up and scale down to solve tricky equivalent ratios. Sometimes you can't just go from this first column to this column by multiplying by a whole number. So we need to use easier compatible numbers or common factors to fill the middle spots in the table. For example, Martha needs 28 strawberries for every 4 smoothies that she makes. How many strawberries does she need for 6 smoothies? Okay, so here's where I'm going to get a little bit stuck. If I put a 6 down here on the bottom, and again, it has to be on the bottom because that's where our smoothies are, smoothie 6, it's pretty tricky to just go from 4 to 6. That's not times 1. 4 times 1 is 4, and it's not times 2. 4 times 2 is 8. If you happen to just know the mixed number or the decimal, then you can use it. But if you don't know the mixed number or the decimal, then we're not going to make 6 smoothies be the next step. We're going to make it be the final step. Right? So we have a couple of options here. I can look for a common factor of 4 and 6. I know that 2 times 2 is 4, and 2 times 3 is 6. So I can use 2's in the middle for 2 smoothies. Now I know that 4 divided by 2 is 2. So 28 divided by 2 is 14. This makes sense. If I make half the number of smoothies, I should need half the number of strawberries. Now I can keep going and say 2 times 3 is 6, so that's triple the smoothies, and then times 3, and if you're not sure, 14 times 3 is 42. Move that off. So that gets us to 42 strawberries. Cool. However, I wouldn't have to use the common factor 2. I could instead use a common multiple. So let's do that. I'm going to say, well, right now she's making 4 smoothies. So I'm going to list out multiples of 4. 4, 8, 12, 16, 20. We'll stop there. And she wants to end up with 6 smoothies. So 6, 12. Hey, look at that. I already have the number here. 12 is my least common multiple. So I'll put 12 here in the middle. 12 smoothies. I know that's too many, but it's really easy to do the math for this problem. Move this out of the way here. And say 4 times 3 is 12. So 28 times 3 is, 28 times 3 is 84. Cool. Now we can work from 12 to 6. 12 to 6. Oh, that one I know pretty easy. It's divide by 2, and I'm pretty sure 84 divided by 2 is 42. Divide by 2. Yep, gets us right back to 42. So you can see that either way, we get the answer of 42 strawberries. Right? So I'm going to go back. Here's my first example with the divide by 2 for top and bottom, and then times 3, top and bottom. Right? We end up with 42 strawberries. So this is scaling up and scaling down. In this example, we made less smoothies. We went from 4 smoothies to 2 smoothies, so that's scaling down. And then when we went from 2 smoothies to 6 smoothies, we scaled up. This lets us live in whole number land, so we don't have to multiply by decimals and mixed numbers. I think you're going to catch on to this pretty quickly. Remember to do the practice page next.